Dysfunctional vet. This is the manifold header for my irrigation system. At the start point, I have a 6-stage or 6-gate orbit sprinkler system which will feed water on different time schedules through these lines. The way the system works, we'll move right here, you'll be able to see this. This is the normal condition. This is open, the water goes through here and it goes on out and it feeds my vegetables. If I want to add fertilizer to it, I would open this valve right here. I would open this valve right here, and I would close this valve. The water is now diverted up into this header. It goes to my fertilizer tank. It's mixed with fertilizer. It then will return through a manifold line over here, and it will come down and it will now flow out through my system. To take this out of use, turn this line off, give it a moment for the pressure to drain down, and I'm planning to put a pressure gauge on here and I'll be able to actually see the pressure drop off. Close the valve, open this one, and it's back into a normal sprinkler system. Now there's no problem with shutting these valves. It's not going to do anything. The pressure in this system is 20 pounds, which is adequate for mixing in the tank, and it's adequate for my drip heads. What I want to show you now is how I'm cutting these all threads for these valves. As you look at this, this is kind of rough, and I'll explain why that was rough in a moment. But I was able to cut this, and it will now thread onto my piece very easily, and I'll show you that now. With this now, with Teflon, I put it on here, I start threading it, and it threads right on. There we go. Now let me show you what I started with and what I end up with so that you can see what I'm doing, and this will save you a lot of money. If you want it to work easily, you have to do it the way I show you. I've tried a lot of different other ways to do this. This is the easiest and the fastest. First, we're starting with a riser. This is a 1-foot riser, which is made for a sprinkler system. We have threads and we have these bands, and what we have to do is we have to cut right against this band so that we have our 2-inch all thread. These are about 97 cents. The all thread as the nipple in plastic or metal is a whole lot more than that. This is how you do it. First, make sure you have a cutter. Make sure that the blade does not have a nick in it. If you have a nick, you've lost it. If you look at this thread right here will come down to a point and it becomes part of this. What we want to do is move up just a little bit on this thing and set our blade in there. And then close down on it. As soon as we start to cut, we now turn this piece right here will turn clockwise, and we will cut right along this band. This is going to fall to the ground when I get done with it. And there's our piece, and it, with a little Teflon, it will thread right on and it will thread straight, and you're good. I saved this piece right here because this is a factory set for threading. I saved this for when I'm working with something I want to use the more difficult end, which is this one that's cut, for putting onto the part. That's what I just showed you on that other thing. Now the next thing that I need to do is finish all these pieces. I've got 4 more to do to have all of the unions and shutoffs, and then I will be assembling the top part of the header. It's about 2 in the morning. I have put together a lot of my manifold. I've altered its design slightly, as you can see from the original. This just makes it a little cleaner, a little easier to see, a little less confusing for some of my viewers. The way this works, and we're going to concentrate on this line right here because it's easy to see. We have a valve right here. This valve and that valve will normally be closed. When we want to put fertilizer into the system, we will open this valve, and we'll close this one. The water is then comes up into the top of the header. It follows this down, and we have a pressure gauge so we can actually monitor how much pressure is going through the system. It'll go down into this. It comes down into this union right here, which will connect into the water meter and the venturi. Now I've offset this just a little bit so that my venturi water meter connection ends just slightly past the end of this, so it'll all be fairly well contained. At some point I'll be taking some sacrificial lambs and building a shelter for this. One of the things that I wanted to do is I want to use flexible hose from the Vault 6 over here to this. I'm having a lot of trouble getting parts, and I went to several different stores today. I'm going to end up probably going on Amazon in a little while and seeing if I can find the parts. But I'm having trouble getting the parts that I need in order to take a water hose, a cheapie, nothing fancy, and cutting it and fitting this to feed from Vault 6 into these incoming lines here. I'll be then using garden hose on the exit side back over here to run water out to my 1/2-inch PVC, where it will then go into the garden and be distributed. The reason for using garden hose and not PVC is I can roll up the garden hose and put it away for the winter. The PVC will be put together with threaded connectors like these right here on each end, and I can unscrew those and move them to storage for the winter and get them out of the way so that I can clean up the garden, till it and that kind of stuff, and then put all this system back out. It'll make it much more portable to have things that are easy to store than to have big long pieces that run from here to there, which was my original idea. I don't remember who coined this phrase, but the story grows in the telling, and this is one of those telling stories. With that said, dysfunctional vet out.